Anybody work it out yet? So you're getting between the 1200 and the 2000, that is giving us what? 8. You get negative 8, right? Plus 40 plus 1005. And that gives you positive 740 Newton meter. Everybody see that? Everybody good with that? I don't understand how you're giving me some silent treatment, you know, guys. What happened to the system? You can't talk? All right. Good?
Yes, sir.
All right, all right. All right, the next one. What about this one here? This one is a little bit more intense. All right. So for this one, it says you must determine the coupling moment acting on the beam. You could take it
Sir,
out
you
of.
can just scroll back up. Want a little snap, sir? Thank you, sir.
All right. Next one. All right. The next one. So this one now, it has a body with a force being applied to it, right? And we all see that. So it's black and the force is being applied to it. Wow. Let me use black. So, right? So that's the force coming down, and it also have a force going up. So they are coupling. They have the same value, they're going opposite direction. Now, we can't know, only thing we know is that they are like this. One is going that direction and one is going that direction. Now, that won't help us to get the distance between them, right? Because they're not vertical or they're not horizontal. So what you have to do, right? We are going to split them into components. So we're going to say one is going, so this one, you know, it have a component in the X and it has a component in the Y. Don't we know that? So we're going to split it into components. All right? So this one is going down. All right? And this one, as we say, you see that it's going, that one is a little bit messy. All right? So it's going, again, it's going, all right? So it's going that way. All right? So that we know. And essentially, it's the same thing if we consider, but really, you know, these forces all act through this point here. Right? We know we have one going down there and one in the blue. Now, the same thing for this one here. We have one force going here. This one is going, so we have one going that direction, right? And we have typically another force going into this direction. All right? So one is going there, right? And one is going here. All right? Essentially. All right? Now, they really act in the same direction. Maybe I should draw this one over here, so too. Just to give you a clarity. So you can put like a box. You put a box up there, you see it. It's the same thing. So you can use any one of the boxes, right? It's your choice. Whether you use the X or the Y. Right? So it's your choice. Nobody else one. Right? Which one, what you want, so what you want us to do from here now? What is it that we need to do? So from here, let me get my writer again. We are going to analyze where are the components, right? So which one of the triangle do we work with? You can work with any one of the triangle you choose to, right? But and do not work with more than one triangle. It will confuse. All right. For the intent and the purpose, I'm going to use one triangle. So I'm going to erase one, all right? And I'm going to erase this one since it's cold over there. The first thing I do now, we're going to identify the components of the forces. So let's take a triangle at a time. All right, first of all, they give you a direction. What are the directions they give you? The 4-3-5 triangle. So for this one, we're going to use this angle down here. We're calling that alpha. All right, so that is alpha down here. How do we find alpha, the trigs? Let us identify them. So what we know is that sine alpha is equal to some ratio there. I will know cos alpha. Can somebody tell me what are these? Sine alpha, what is sine alpha? What's the ratio of sine alpha for the first triangle? Hello?
4 or 5.
4, 5? 4 where? You mean 4, 5? What do you mean by that? I'm not sure I
4
understand.
over 5. Oh.
4 and 5. So let us see. We're going to look now if that's the case. So what we know is that alpha is right down here. Right? So that side, sine is that side, which is going to be 4 upon 5. And the cos now, which lie right beside it, is going to be 3 upon 5. So we know those two things. All right, the next one that we know now. All right, so those are one. Next one. All right, come now. The next one now is going to be this angle here. We're going to call this theta. All right. So this one now, we're going to call this sine theta is equals to, now, if you look at the triangle, this one may confuse you, so let me just clarify. The horizontal is 3, and the vertical is 4. All right? So, and the hypotenuse is 5. So, therefore, sine is going to be what? Sine is going to be what?
3 over 4, 5.
You sure?
Mm.
It confusing you how the triangle is drawn? I can redraw it, you know, if I draw it this way. And I draw it that way. You see if yeah. What about that? Do you see it now? You see it better if I draw it that way? So this is 3, this is 4. However, the theta that you are referring to, it will be this. This will be the same theta. Can you see it better that way?
Yeah. Yes, sir.
So sine, look, the 3 is horizontal. The 3 is horizontal, you know, and the 4 is vertical. So the 4 must represent on that side. So you can look at it from any angle there. Let me clear this up.
Sure.
You look, look where you must look where the ratios are. The ratios, look at the ones that are horizontal and look at the ones that are vertical. 4 is vertical
3 over
and 3 is
5.
horizontal. So therefore, when you're writing the sine must be pointing to that side, which is going to be 3 upon 5. And cos is going to be pointing where? Beside it, like beside it says 4 upon 5. Agree? All right.
Sir.
What I want you to do for me now, we're going to identify the component of the forces now. So we look at this triangle up top here first. Go to one up top. The component, what are the components in the x direction? Is it going positive or negative x direction? Is it negative x direction, but what is the component in the x direction? So in the x direction,
10.
It's going to be 10 what? Which one are the ratios? Sine or cos?
Sine.
Sine? You sure? When it lie right beside the angle is sine? If you like something like right beside this here, is it sine or cos? If the thing lie right beside,
Which one are you looking?
one up the top, one up the top.
Oh.
This one up here I'm dealing with. So we were tick a while ago. Yeah, remember
Yes,
say the alpha is right here now. Alpha angle is right there. You can see it right there. That angle I'm dealing with. So if it's this angle I'm dealing with right here, which is my alpha angle, all right? That angle I'm dealing with right there. If I'm dealing with that angle, then it's clearly it is cos.
Yeah.
Cos alpha, not true. And y.
Adjacent.
What is the y now? What is the y now? Y direction of the component. The component is coming down in the red. See it here? Coming down in the red. The angle theta is right here, so. What is the, which ratio is that now? You should know that one now.
Sine.
10 sine alpha, because alpha is pointing to which side? To that side. See there? It's
Opposite.
pointing to that side. So it must be sine. So you get the component now. What about the one down the bottom here now? Theta is up in the top here. The angle is up in the top here, theta. So you're going to give me the component just the same. What is the x component for this one?
Cos.
For x is cos. Look good again. It is 10. What is the ratio for the in the x direction?
Oh, it's sine. Sorry, sir. Sine.
So it's sine theta for the component. And then that is the f of x component. All right, what is the f of y component for that force?
The opposite of cos.
And it is it is positive and it is going up. The line beside it says 10 cos theta. Now you can simplify all of these. Let's simplify them. So we're going back up to the top, alpha now. So this one here is going to be 10. What is cos alpha? And 3/5. And what is
yes, sir.
And the other one here, 10 sine alpha is what? 4/5. So therefore, this gives you one give you 6 kilonewtons, and one give you 8 kilonewtons. You see that? This one gives you 10. What is sine theta? Down here. What's sine theta? What is sine theta here? What is the value of sine theta?
3/5.
3/5. So this gives me what now? 6. Yeah.
0.6.
So it go for x. So it's the same value, and then this gives me what now? What is y now?
4/5.
All right, so let's do it. It's 10 times the ratio is 4/5. So that gives me 8.
8.
All right. Now can we find the couples now? So what you're going to do now, we're going to look at what are the forces that we are going to concentrate on. That's a big deal here now. So the force one, first we're going to look at the blue forces. The blue line, the pale blue line we're going to look at. Which direction are they going? They tend to be going that direction. That's one. And the next one is here. Going in that direction. Do you see that there are a distance between them? Where are they acting from? They are acting right here. Both of them. And here. Do you see the point where I'm putting them? Both at the tip of the force. One is right here. Do I have to put a different color for you to see it? All right, let's go.
Yes, sir, because
look, you see it? One is acting there. See the orange? And one is acting right here. You see them? You see my two dots? Now, so one is acting there. So let me draw it up there. Let me put the force up there. So one component is actually right here. Oh, Lord, that's not draw two right. Let me go again. So one is going here. And the other one is coming right here. Now look, let me quickly get to it quickly because I know the time going. So look, the distance between them is what we work with. We have two blue forces. What are the forces between them? From the tip of this one to the center of this here, can I get a different color? From here to down here, so is 1. From here to down here is 1. So how much that give you? 1 and 1 make how much? Come on, the 2. You see it? So the moment, so you can get a moment from them now. So let's write the moment now. So the moment, some of your moment, right? Your copy moment, it will give you a moment. For those blue, it is going to be the force. And what's the value of that force in the x direction? We see that it was 6. So it is 6. Both of them are same. 6 times, what's the distance between the two forces? 2. Is that going clockwise or anti-clockwise? We can take let's work with anti-clockwise, clockwise as positive. Is it going clockwise or anti-clockwise? Anti, so we're gonna call that minus.
Clockwise.
This is, no man, it is anti. It's anti, it's spinning the body in the opposite direction. Look good.
Okay.
Good.
Okay,
It's
from the
spinning
top
it
come round.
around.
Okay.
Yeah, it's going to tend to turn the body this way, up that direction. And this one is turning in that direction. So they must give a spinning moment. But it's spinning in the anti-clockwise direction. So all right, the next one. Where are we again? I can't find my pointer here now. All right, next one. The next force that we are dealing with, the one in red. Let me show you them. The one in red is like it's acting right at the tip here. Let me just show you. It's right here, so one is coming down right through here. See there? One is running there, and one is going up here. We have this one here already. So see them there? You see them? All right? So I'm moving this one here for clarity now. So you're not confused. So you see the components them now. All right? You're okay with that now? You see them? All right?
Yes, sir.
Right. You see the components, where the components are. Right? So I just leave the components alone. I don't take out everything else and make you see where the components are. You see the components and you see the force. So the force is, so if we're not dealing with the force, we're dealing with its component. So its component in the red now, the red is going to turn the body that way and this way. So it's going to be giving us a clockwise moment. So the clockwise moment now, what's the distance between those two forces? Come on. 4. Everybody say that it is 4? Is only one person say that it's 4? It's 4 for 2. See it here? That distance there. Right. So one, remember, you know, one is coming right through like a sliding vector. See that? And the other one is coming right through like a sliding vector. See it? So there, and the distance between them is 4. So it gives a coupling moment. And so let me write that down now. So therefore, it is going to be plus 8, because that moment is 8 times 4. And so you get what here? Minus 12 plus what? 32. And so how much that gives you? Isn't that 20? 20 Newton meters. All right? And so you have it up here. So 20. All right? All right? You see that? Everybody follow that?
Hold it right there, sir.
Everybody follow that? It's not the complete thing that, you know, hold on. Let me make it a little bit small. See it here now. That's that.
Thank you, sir.
Right. All right. Let me just look at another one briefly. Don't know if we have enough time, but let's look at this one here. All right. Yeah, the other one is a little bit more complex. Look at this one. This is the same thing that will happen here. It has component in the X and in the Y. You need to find the component of the forces. So you'll have a component going here. Let's see if I can use a different color. So you have a component going here. Right? Can you see it? And you have one going this way, and put another red. So you have two components. One going that way, and it's similar for this one. You'll have one coming this way. I have one going this way for this one. All right? So that one going that way, this one going that way. Can you see the forces now? You see you see them? So one going this way and one going that. It's the component you're working on. Now, what are the components of the force? So first, we need to find the component for the force. If you were to draw this, you can map out a triangle. See it? And if you were to draw this one, you can map out a triangle for any one of them. You could extend this and map out a triangle. See a triangle here? All right. Now, that triangle, let's map the triangle. So from the triangle now, what are the forces here? So we see that we have one going up here, one going down here. All right. Let's map them now. Let's find the component of the ones up top, and they'll be similar to the ones on the bottom. So for the F force, it says F is 150. So we know the value for the F. So this is 150. Both of them. Pounds, of course. Now, how do we find the component now? We look at the triangle, 3, 4, 5 triangle. We can call this alpha. All right. And you can call this theta. So let's write the component for the top one. Just the same thing again. Sine alpha is what? Sine alpha is equals to what? 3 upon 5.
3 over 5.
And cos alpha is 4 upon 5. Right? All right. For down here, sine theta is equals to what now? Now you have to know how to visualize which one is horizontal and which one is vertical. The 3 is vertical and the 4 is horizontal. So that will tell you how to write it. Right? And this is 5, the hypotenuse. So therefore, sine is going to be what? 3 upon 5.
3 over 5.
And cos is
4 upon
4 upon
5.
5. Right. So therefore, we know that they are similar. So what are the components now? Let's write the components now. So the components, fx for the first one, first triangle up top, fx is what? In the x direction. It's going to be a cos. 150 cos alpha, which alpha is going to be 150 times 4 upon 5. Not sure. And then f of y is going to be equal to 150 sine alpha, which is going to be 150. And what is, this is 3 upon 5. How much this one work out to? One is 120 and the other one is 90 pounds. And the other one down here, who's a different color, is going to be f of x and f of y. F of x component for this triangle down here, the triangle in the x direction is in the blue. All right, so the one in the blue direction, what do we get from that one? Isn't that a cos? So it is 150 cos theta. While this one is going to be 150 sine theta. So let's write what the force is equal, calculate to be. There's 150 times cos is 4 upon 5. And then sine 150 sine is 3 upon 5. So this one is going to be 120 again, and this one is going to be 90. So they are the same value, right, in each direction. So you can see that they are comparable. So the y is what? 90, 90, 90. And the component here is going to be 120, 120. I want to put it where it's not, you can't see it. So you see that they are 120? Everybody see them? You see the ones that we are supposed to be comparing? All right, the two in red now. Give me we're taking clockwise to be positive. So for a moment, clockwise to be positive. Give me the moment for the two red. One going up and down. What is the distance between the two red forces? Anybody see them? What's the distance between the two red forces? Come on and talk fast on the time.
4 feet. 4 feet.
You see them? You see them now? So it is going to be
4 feet.
90 times 4. Is it clockwise or anti-clockwise? You not like it anti? You not like it anti that one turning the body that way and the other one turning?
Man. Pushing down and pushing up.
Right. All right, the next one. What is it, plus or minus or the next one? All right, I don't even analyze it. What's the next one? The next one is turning the body clockwise or anti-clockwise. Isn't it? This one is coming the body that way. And that one, that's the blue. And the other one is turning the body this way. Blue, blue. So it's anti. So it's going to be what? 100, 120 times. What's the distance between them? Is it 1.5? You see the 1.5? Who don't see the 1.5? All right. Next one now, we have another force. Where's this one turning the body? The 200 force. They are parallel. Clockwise or anti-clockwise? Huh?
Clockwise. Clockwise.
Okay. So they are clockwise. So therefore, what this work out to be for you? 4 times this. How much is this one? How much is this one here? Am I correct here? So how much is that one?
Minus 360 minus.
How much is that? Is that correct? Was it 90 times 4? And that is
360 minus 3.
Pardon me?
Yes, sir. Correct.
So what it's saying here, these two would have cancelled each other. If this is correct, all right? So that would
Minus
go,
300.
and those would go, those cancel each other.
Minus
Answer
360.
minus 360 in the anti-clockwise direction, counterclockwise. And this will be Newton meter. Right? So that's what is saying. I am you have to look good, make sure. So that is 2 there, so that was 2. No, that was 3, sorry. That was 1.5. Two of them are 1.5. It was 90. We're supposed to multiply with the first one. The first one was the red. Yeah, just checking.
Yes.
And the Y was the X was 120. And then you had that turn in the body clockwise, which is plus. So we had 2 minus and we had 2 plus. Okay. So that's what we're getting. All right. So basically getting 363 3 something. All right. So that's that. All right, gentle folks. Yeah, with the power outage and all of that. And we kind of start a little bit late. But anyway, I trust that you understood what we discussed. All right. All right. So we're moving on to another topic. Next week we will I suppose we'll find out what we're doing. We'll decide if we do reinforcement because we're gonna have another quiz shortly. All right. So
Okay. Need some reinforcement, sir.
well, you're gonna have another quiz. How was the quiz? Because I don't know, I haven't analyzed anything yet. How was the quiz? Do you all get to do it?
Challenging.
I hope you all got to do it, All right. Hope you all did it. All right. Just drop your name in the chat and that's it for me. All right. Just drop your name
How
in the
soon is
chat.
the next quiz, sir?
Pardon me?
Next 3 weeks? How soon is the next quiz? The next 3 weeks?
About the next week. Awesome.
Next week?
Yeah, yes,
Mercy.
yes. Yeah, man, because you should have gotten these quiz. These quiz are late, You're what we call late. You're pretty late to these quiz. Right. I say there was another person who joined. I'm trying to remember. Anyway, sure you are normally. Oh, who's missing today? Powell. I don't see Powell not around. Powell probably joined the other group.
Morris.
Who's that?
Morris missing too, sir.
Mm-hmm. All right. Okay. Evans is here. Evans, you're here? No.
Yes, sir.
Yeah.
And Watson. Watson, which group you're really from?
Sir, we need extra classes, sir.
Me not have a problem. Me not have a
Road,
problem, man. Me not have a problem with you. Me just ask a question.
Okay, sir. Mr. Dr. Road class. But I need reinforcement, sir. So anytime I see online, I have to grab it, sir. Long and short of the conversation.
I do have a problem with that, boss. I have no problem with that.
Don't tolerate me, sir. Nothing else.
No. Remember, well, of course, I told the student for this class that they should join Dr. Rowe class if it's more convenient for them because this group is small. So be reminded that I did that. Just be reminded. I know that you're from another one. I know that for certain. Because you're in the chooser class. Wasn't it so?
Yes, sir.
Yeah, man.
Yes, sir.
I recognize.
Thank you, sir.
Right. So I noticed that Powell is here, you said? Or Powell is absent? Who is absent today? Powell and Morris. Powell and Morris absent today. Only Evans passed through from this class, and Williams not here. All right. Okay. I'm just doing a check. Just doing a check. All right. Yeah, because I did tell them to join other classes, because we might close up this tutorial. But anyhow, no problem. All right. So take care. Have a good one.
Same to you, sir. Thank you.
All right. Sure. Good, bro. All right.
Yes.
Mm-hmm. Nice.